Are you ill? No, just feeling a bit off. In this question, we are given a binary representation of an integer and we wish to return the number of steps to reduce it to 1 under the following rules. If the current number is even, you have to divide it by 2. If the current number is odd, you have to add 1 to it. We know that binary numbers are composed of zeros and ones. The decimal number 6 in a binary number representation is 110, which is 2 to the power of 2 plus 2 to the power of 1. To solve this question, we need to understand that the last digit of any even binary number is 0, and the last digit of any odd binary number is 1. To divide an even binary number by 2, we only need to chop the last digit off. For example, 110 divided by 2 is 11. Since dividing by 2 means minus 1 from each power of 2 in 2 to the power of 2 plus 2 to the power of 1, which is 2 to the power of 1 plus 2 to the power of 0. That is 1 in the binary number. For any odd binary number, adding 1 turns it into an even number with the last digit 0. And a 1 is carried over to the second last digit. Like 101 plus 1 is equal to 110. If there isn't a second last digit, the 1 is carried over and will result in a new bit. Like 1 plus 1 is equal to 10. So how do we approach this problem? Suppose we are given the binary number 1101 and wish to reduce it to 1. We do not change the original binary number and instead use a variable carry to record a carryover digit. We start from the last digit of the binary number. Since it is odd, we first add 1 to the number, and a 1 is carried over to the second last digit. Now the number is even, we divide it by 2 by chopping it into 110, with a carryover digit 1. This takes 2 steps. Now the number is still odd, we add 1 to it and divide it by 2. So that we have 1 with another carryover digit 1. This takes 2 steps. 1 with a carry digit 1 is even, so dividing 2 means chopping 1 more digit, which results in 1 with a carryover digit 1. This takes 1 step. Now the number only has 1 digit. The carry digit will result in 1 more digit to the left and result in the binary string 10. We know that 10 is an even number, so we divide it by 2 and obtain 1, which is our last step. Finally, we reduce the number to 1 in 6 steps. Now let's talk about implementing this process in code. We first initialize the variable L to be the length of the input string -1. The variable carry is initialized to 0, step count to 0. The function enters into a while loop and reads the string from right to left and iterates when L is larger than 0. In the while loop, the function checks the value of the last digit of the binary number and adds the carry value. If the number is even and there is no carry, the result will be even and divided by 2. So we increment the step count by 1 and set the carry to 0. If the number is odd and there is a carry, the result will be even and divided by 2, except we need to carry over a digit. So we increment the step count by 1 and set the carry to 1. When the number is even and there is a carry digit, or when the number is odd and there is no carry digit, both results will be odd. So we add 1 to it to make the result even, and divide by 2. That takes 2 steps, so we increment the step count by 2 and set the carry to 1. The while loop stops when we reach the first digit of the given binary number, which is always 1. After that, we check the value of carry. If it is 1, it means that a carryover digit 1 needs to be added, which gives 10. So we need 1 more divide to make it 1, which is 1 more step and increments the step count by 1. Finally, the function returns the step counts it takes to reduce the binary number to 1. This is the full solution to problem number of steps to reduce a number in binary representation to 1. I hope you found this video helpful. Please like, subscribe, and leave a comment. Thank you.